Hey guys, the square root of 2 is irrational. Maybe you've heard that. And what that means is that none of these equations I've written here have whole number solutions. But we're going to make one change and there's a totally beautiful story. If we add a 1 to the right-hand side, we actually get infinitely many solutions, and that's what I want to explain today. Today we call this Pell's equation, but it was actually first extensively studied by Brahmagupta in India about 1500 years ago. We can graph this equation, by the way, and it's a cool hyperbola, and we're looking for those points on it where both coordinates are whole numbers. Now, trial and error, it's easy to find a few small ones, like 3 squared is the same as twice times 2 squared plus 1. Maybe if you try a little bit more on paper, you could even find this one, 17 and 12. But even with a computer, it's hard to get very far because these are the only solutions so far, and they grow pretty quickly. So to find more, we really need an idea, and that's what I want to show you. And really, go ahead on your computer and see if you can find 15 more of these. It's actually really hard without some sort of insight. And the insight is nothing more than factoring. We can take this equation here and think of it as a difference of two squares if we allow the square root of 2. Now, I know what you're thinking, that's not a whole number, but stay with me till the end. What we know is that if we find one solution, in this case 3 and 2, that's got to make this equation true. And if you don't believe me, just FOIL out both sides and check that you get 1 at the end. I'm going to do something that might seem fairly obvious, but I'm going to square both sides. And notice the right-hand side is still going to be 1. And I brought our solution table down here just to see what's going to happen. But after I square both sides, I can just expand things out. You know, I get a 17 plus 12 root 2. Over here, I get 17 minus 12 root 2. And what do you know? I get exactly the next row in our table. That's kind of crazy. And of course, we know it's a solution because we multiply these things together and get 1. That was the same as our original equation, right? These are all equivalent steps. What we've just done is if we start with the pair 3, 2 and square both sides, we get 17, 12. I wonder how we could get the next one. If we do exactly the same thing, but instead of squaring both sides, we cube both sides, the algebra is a little bit more messy, but at the end, you get 99 and 70 as your two numbers that show up. And sure enough, that was the next thing in our table. And I love that such a beautiful idea unlocks this problem. If you thought this was cool, please give me a like or a follow. In fact, if you want to comment and share this video with a friend, I'd love to get this video out to many people who might be interested.